Okay, so this video is going to be for lesson 6 in trigonometry, and it corresponds to page 241 in your workbook, so make sure that everybody's open to page 241. This should be a really quick lesson. We are only going to do 2 examples. So 2 examples we're going to go through, and then I think I have 3 homework questions for this. Okay, so what we're getting into now is the problem solving, using trig ratios involving problem solving. So it's going to be the exact same thing SOHCAHTOA, except there might be one additional thing that we're going to be doing with these questions. So what it says is Carmen is a surveyor who is using a transit to determine the height of a tree. So here's the little transit here. The transit is placed 52 meters from the base of the tree. So this triangle here, they do have the 52 meters labeled, but let's put the 52 as well on the triangle. And then it says that the angle to the top of the tree is measured to be 12 degrees. So this angle here is 12 degrees. Based on just this information, we could use trig to calculate this piece of the tree. Do you guys agree with that? And I could say that that is x. So let's put an x there. But what they are going to ask us for this question is they're going to say, what's the total height of the tree? And in the question, they tell us what the height of the transit is, and they say this little transit is 1.8 meters. So from here to here, it's 1.8 meters, which means on the tree trunk from here to here is 1.8 meters. So we're doing the exact same skills that we did already, and we're going to calculate what x is. And if they want the height of the tree, what am I going to add to whatever number we get? 1.8, and we're done. So let's calculate the height of the tree to the nearest tenth of a meter. So again, ignore the transit for now. Just focus on your triangle, and let's figure out the tree from here to here. So this blue x. So let's label according to 12 degrees. X would be my opposite side. This is the hypotenuse of the triangle, and 52 would be my adjacent. I need to box in what I'm looking for, which is my x, and my given side, which is my adjacent. According to SOHCAHTOA, what trig ratio do you think I would pick? Tan. Yeah. So the tan of my given angle, the given angle is 12 degrees, is equal to O over A, which is x over 52. Multiply this side by 52. Multiply this side by 52. Keep your numbers stored on your calculator. So x, which is only a portion of the tree, 52 times tan of 12. So that would be like 11.05. And I'm just going to do dot, dot, dot to show that we never round until the very end. This will be huge in measurement when we do start that next week. And then to that number, Cohen, what do I need to add? 1.8. However height, whatever height the transit was. And then, actually, I'm not even going to call this x, right? The tree height of tree is, so take that number and add 1.8, and then we could round at the very end. And the question said round to the nearest tenth. So I look at this decimal here, and I look at 1 to the right of it. So that becomes a 12.9. The height of the tree is 12.9 meters. And you're done. For these word problems, especially where we're adding something else, give a sentence. Yes. Your exam. Yeah. And then the next example we do, it's going to be an exam question as well. Okay, determine the angle of the base of the transit with the top of the tree. Okay, so here's what this would be. So the base of the transit, you guys, is basically right here, right? They want this angle here is what they want. So they want the angle from the base of the transit to the top of the tree. So it's not like that 12, because that was the angle from the height of the transit. So they want the angle from the base of the transit. I kind of drew this a little bit off, but it would be, it'd go up and then down. So what they want now is they want the angle down here. I know that the transit is 52 meters from the tree, so that never changed. And then Sebastian, what else did I calculate that I now know? The height of the tree, so 12.9. So again, for something like this, you're only going to get this right basically if you got this part right. Okay, so they want x based on 12.9. Opposite, hypotenuse, and adjacent. We're finding an angle, so I need to box in two sides, and I always box in two given sides. Cohen, what trig ratio do you want me to use? Tan again. Tan of angle x is equal to O over A, which is 12.9 over 52. This is an inverse function. So the inverse tan of 12.9 over 52 is equal to, and then they say to the nearest degree. Hermes, what did your calculator say? 14 degrees. And then if you were to say a sentence for this, you'd say, you know, the angle formed from the base of the transit to the top of the tree is 14 degrees. Number 2, we do not do. Okay, number 3, this guy, star it. Super important question. This one will always creep up on an exam. All right, so let's actually start in the second sentence here. In the diagram, the man on the ground is standing 12 feet from the wall. So put the 12 in. So in the diagram, the man on the ground is standing 12 feet from the wall. So that guy would be 12. The angle of elevation from his eye to his wife, who's up here, is 62 degrees. You guys, the angle of elevation, it's always measured from the horizontal. So remember, this guy, he could look straight ahead, or he could look up at his wife. So that is 62 degrees. If I said, put in like the angle of elevation is equal to the angle of depression, even though we might not need that, see if you could find that backwards Z in this example, and where would the angle of depression from her eyes be? So where would you put 62 degrees from her eyes? And the Z would be this guy here. So 62 degrees would also be there, right? Because the wife could look straight ahead, or she could look down at her husband. So that's 62 degrees. So I'm just going to erase that for now because it didn't ask for that just yet. But I'm going to put the 62 in. 62 degrees. Okay, let's see what else it says. The man's eye level is 6 feet from the ground. Basically what that's saying is he's 6 feet tall. Even though like you could argue that he's got a forehead and stuff like that. Just assume for these questions he's 6 feet tall. So this guy is 6 feet tall. These are going to be calculate the height of the building question. So if he's 6 feet, then I also know that the building from here to here is also 6 feet. Okay. His wife, her eyes are 5.2 feet from the top of the building. So her eyes are 5.2 feet from the top of the building. So this would be 5.2. Therefore, this piece of the building would be 5.2. And then the question is going to be, determine the height of the building will be the question. So what's the only thing we need to do? Calculate what, basically? We're looking at the triangle. Jack, what am I doing? Yeah, this side of the triangle. That's all I got to do. Once I find that, Sebastian, what am I going to do with this? When I find the length of this on the triangle, what do I do to this number? That's right, add 5.2 and add 6. So let's do that. So 62 degrees, this is the opposite. This is the hypotenuse, and 12 would be my adjacent. I'm going to box in what I'm looking for the triangle, the height of the triangle. So I'm going to box in my opposite side and my adjacent side. Another tan ratio, TOA. So the tan of 62 degrees is equal to opposite over adjacent, which would be x over 12. We need to solve for x, so get rid of that divide by 12, multiply both sides by 12. X would be equal to 12 times the tan of 62. .5687. Are you guys getting the same answer? So I'm going to write 22.56 ... to show that I'm going to carry all those decimals. To that, I'm going to do what Sebastian said. So he said, if I'm finding the height of the building, I've just now found this piece, which is 22.56. The height of the building would be that piece plus the 5.2 plus the 6. Height of building is that number plus 5.2 plus 6. 33 to the nearest tenth of a foot, so 33.8 feet would be the correct answer. Okay, so we are done that question, and I believe that's it for the lesson. So I'll give you your homework. So I think I only have 3 questions that I'm assigning. Yep. I want you to do number 1. I want you to do number 3A. And I want you to do number 4. And I'll set up number 4 with you. Okay, so what number 4 says, it says a totem pole is being placed in a 2-meter deep hole in the ground. So label where the 2 meters is. So this little hole here, that guy is going to be 2 meters. And then what it says is 2 ropes are attached to the top of the totem pole, and they're used to hold the totem pole upright. The ropes are anchored into the ground on opposite sides of the pole, and each rope is 19 meters long. So what it says is 2 ropes are coming out of the top of the totem pole, and they're going to be anchored to opposite sides of the totem pole, and each rope, it says, is 19 meters long. Then the last piece of information it says is each rope is 19 meters long and is anchored into the ground 12 meters horizontally from the center of the totem pole. So the center of the totem pole out, this would be 12 meters. Okay. So from here, what do they want us? Complete the sketch, which we just did. Calculate to the nearest tenth of the degree the angle of elevation of the top of the totem pole from the point where the rope is anchored. So here's where the rope is anchored. The angle of elevation, remember, it's always measured from the horizontal. So they want this here. So for B, you're going to be calculating that. So you're going to use trig to get that. And then C, I believe, is going to be the height of the totem pole. So you're going to figure out what this length is here. You'll put an X here. And what are you going to add at the very end when you're figuring out the height of the totem pole? 2 meters is how you're going to do that question.